Hello, welcome back to Cinderella Math. Today we'll be analyzing the different types of roots or zeros or solutions, whatever you want to call it, that a polynomial equation can have, and then we will actually be finding the roots. By the different types, I mean like imaginary, rational, real, positive, and negative. Alrighty, so I'll be using a CUDA software sheet to do this. Let me find that. There he is. It's under Algebra 2, and the title of it is Analyzing and Solving Polynomial Equations. I would say you might be learning this in an advanced Algebra 2. I'd really probably put this more toward a pre-calculus level, but it could go for both. Alrighty, before we actually get into this, I want to just kind of go over some definitions real fast. Let me close whatever is behind here. That's annoying me. There we go. All right. So let's do just a few definitions. If you know this already, you can just fast forward until I'm actually doing number one. So the directions are tell the number of complex roots, the possible number of real and imaginary roots, the possible number of positive and negative roots, and this really should say list the possible rational roots, and then find all roots. This is you got to do a lot of stuff before you even solve. But what do all these words mean? And again, if you know this, just fast forward. If you're thinking of the number system, we have real, we have imaginary, and then when these two get together, this whole shebang is the complex. Okay. All right, so imaginary is going to be anything with an I. So if you're taking the square root of something and it's a negative, that's where you get the I's. And these always come in sets or partners. So there'll always be an even number of these. So if you have x equals I, you'll always get negative I with it. If you have x equals 5i, you'll always get negative 5i with it. So they always come in an even number. You'll never have one imaginary or 5 imaginary solutions. This will always come in an even number. Okay, over on real's anything without an I. So with real, we get irrational. So that's like square root 7. That's a real number. It's not imaginary, but it's ugly. It's irrational. 3 plus or minus root 5. That's actually 2 irrational numbers. But then we can also have rational. Rational is anything that can be written as a fraction. So a half, negative 3/4. 5. 5 could be written as 5/1, right? 100. Any of those are rational. And both irrational and rational could be positive or negative. Okay? So that's kind of some definitions there. Now I want to show you something called Descartes' rule of signs. So yes, this is René Descartes, a famous philosopher from back in the day. Descartes' rule of signs. And again, if you already know this, just skip past. All right, if you take your function f of x and you count the sign changes, that is how many positive real answers or solutions you will have. And then you decrease it by an even number. So like if you get 3, subtract by 2, it could also be 1. If you get 4, subtract by 2, it could be 2. Subtract by 2 could be 0. So it's that number of sign changes and then decreased by an even number. Okay, and this will make more sense once we get into well, I'll do an example actually. So let's say, just real fast, we have a function 10x cubed minus 5x squared plus x plus 3. So what you want to do is you say, okay, he's positive, negative, positive, positive. How many sign changes do we have? 1, 2, and then that one did not change. So this would have 2 or 0 positive real solutions or roots or whatever you call them. Okay? That's how many positive. So you're probably wondering, how do we get the negative? You're going to do the same thing, but instead of f of x, you're going to do f of negative x. Count the sign changes, and that will be your negative real. So if this is our function, let's do f of negative x. So that would be negative x cubed is negative. So that would be negative 10x cubed. Negative x squared stays the same. This would be negative x, right? So here's a trick. Only the odd powers flip signs, right? Because a negative squared is positive. A negative to the fourth is positive. So it's only the odd powers that are going to change. So this one changed and this one changed. Everything else stayed the same. Now write down the signs. Negative, 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 negative. No change, no change, no change, no change. This would have 0 negative real answers. Okay? And then the last rule we need to know, again, if you already know this, fast forward, is the rational root theorem. It's also sometimes called the rational zero theorem. That says if you have a function ax to the n plus bx to the n minus 1 plus c x to the n minus 2 plus dot, 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 let's say p, the possible, now this doesn't mean that they're answers, but the possible rational, which are pretty, right? Which means it can be written as a fraction, solutions are all the factors of, take the last one, all the factors of p. So p, list your factors, and then take the very front coefficient, that leading coefficient a, list his factors, and then divide. And then each one gets a plus minus. So example, f of x, let's say it's 2x to the 5th plus 8x cubed plus 9. You would take all the factors of that back constant, so 9. What factors does 9 have? Well, 1 times 9, 3 times 3. No need to repeat yourself. And then take all the factors of the front number, 2. That leading coefficient is 1 times 2. Divide. 1 divide 1 is 1. 1 divide 2 is a half. 3 divide 1 is 3. 3 divide 2 is 3 halves. 9 divide 1 is 9. 9 divide 2 is 9 halves, and then give all of them a plus minus. If that function, not saying it does, but if it has rational roots, these are the possibilities. Okay, now we're actually ready to do this worksheet. This will take a while. I am only going to be doing the odds, and I have about an hour until I have to go. If for some reason I don't get this done, I'll do a part 2. But I probably am going to be talking pretty fast here. Just slow down the speed on YouTube if you need to. And again, I'm only going to be doing the odds. So I'm going to just go ahead and white out the evens. Okay. First, I mean, the order that you do these doesn't really matter. First, how many total is going to be the highest power? So you're going to have 4 total or 4 complex. That includes imaginary and real, right? Complex is everything. Roots. Okay. And then I like to do the imaginary because I know they'll come in even numbers. So looking at our 4, what are the even numbers? So we could have 4, 2, or 0 imaginary roots. So it's always the highest even number you can get and then go down even numbers. So down by twos, right? So wait, if you have 4 imaginaries, though, you would have 0 reals. If you have 2 imaginaries, you would have 2 reals. And if you have 0 imaginary, you would have 4 real roots. So you kind of just take all the possibilities and reverse it. Because you know it has to add to 4. 0 plus 4 adds to 4. 2 plus 2 adds to 4. 4 plus 0 adds to 4, right? Because you know you have to have 4 total. That's the key there. Okay, let's look at f of x, and let's look at the sign changes. So this is positive, right? Because there's an invisible 1. Then the middle one's negative, and the last one's negative. Ignore the 0. This has 1 sign change. So that means we're going to have 1 positive real root. That doesn't mean it's rational. It doesn't have to be pretty. It just has to be real, which means it's not imaginary. Okay, now let's look at the signs of f of negative x. So only anything with an odd power would change. This has an even power, so that'll stay. This has an even, that'll stay. And then this has no x's, so it'll just stay. We get 1 sign change. So this will have 1 negative real root. Okay, so that's kind of all. Well, nope, I lie. Now we need to get the possible rational roots. Take all the factors of the back constant, ignore that it's negative. So 36, what can go into 36? 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6, but you don't need to write it twice. Divide the front number, which is 1. What goes into 1? Just 1. So anything divide 1 is going to be itself, right? 1 divide 1 is 1, 2 divide 1 is 2, 3 divide 1 is 3, and so forth. So you're just going to copy that list over, giving each one of them a plus or minus. So if, not saying it does, but if this polynomial has rational roots, they must come from that list. Okay, now we can actually solve it. Since it is a trinomial, I'm going to try to factor it, and I factor with something called the magic X method. If you have a different method, do your method. But I put the invisible 1, I make an X, and I do the first number times the back number. So that would be negative 36, and then the middle number, negative 5, goes here. Multiply to the top, add to the bottom. So what multiplies would be negative 9 times 4. That would multiply to negative 36 and add to negative 5. So we can break this into 2 factors. See how this is x to the 4th? Cut it in half. 2x's for me, 2x's for you. Take these numbers, minus 9 plus 4. Set to 0. This would be x squared equals 9, root, x is 3. Don't forget your plus or minus. Set to 0. X squared is negative 4, root, x equals 2i. Don't forget your plus or minus I because we were taking a negative root. Answers. So final solutions on number 1 is plus or minus 3. So there's your 2 real solutions and plus or minus 2i. So we ended up with this situation. There's no way to tell that though. But there we go. Ooh. All right. I'm going to keep going. Number 3. Okay. Let me again just white out everything. All right. We know we're going to have 3 answers total right here. So we're going to have 3 total, which is 3 complex roots. And again, complex covers both real and rational. All right. Do the imaginaries. We know imaginaries come in pairs. So that could be 2 or 0, because we can't do 3, because that's not a pair. Imaginary. Right? They always are going to be even. And the biggest even number I can get in there is 2. Can't go up to 4, because we don't 4 is not this won't have 4 solutions. Okay, so if we have 2 imaginaries, that would leave 1 real. And if we have 0 imaginaries, that would leave 3, because again, this has to add up to 3, this has to add up to 3. So those are our possibilities for real roots. Okay, let me just go ahead and do the possible rational solutions. So take 6, ignore that it's negative, list out its factors. So that's 1 times 6, 2 times 3, divide the factors of the leading coefficient, which is just 1. So 1 divide 1 is 1, 2 divide 1 is 2, and so forth. If this thing has pretty answers, it must come from that black box. Those are the possible rational solutions. Not saying it has those, but it could. And now let's look at our signs. Let's look at the signs of f of x. There's a positive 1, negative, positive, negative. 1, 2, 3. So we're going to have 3 or 1, because again, you go down by an even number. Positive, real solution, root, whatever. And now let's look at the signs of f of negative x. So again, anything that's odd, going to flip. So this was positive, but since he's an odd power, flip him. The even will stay the same. This is an odd power because it's got a 1, flip it, and the naked number will stay the same. So this will have 0 negative real solutions, roots, whatever, because there was no changes. Okay. Okay, now we can try to solve this. So looking at the original problem, I'm going to rewrite it in black. X cubed minus 2x squared plus 3x minus 6. I'm going to try to do grouping on it. If we do the grouping method, which only works with 4 things, put them in 2 sets. I see the GCF of the first one would be x squared, leaving x minus 2. And the GCF of the second one would be 3, leaving x minus 2. So, I'm just checking my notes here. Yep, that looks good. And then after you group like that, you put the lonely things together. So you'll have x squared plus 3. And then you pull out the guy that happens twice, you just carry that down once. Okay, there's your factors. Set to 0. This one will whip around and be x equals 2. Set to 0. This one would come over, be x squared equals negative 3. Take the root, take the root. So that's I, because he was negative. 3 would stay in. Don't forget your plus or minus. And then we had 2. Answer. Roots. So we had this situation. We had 2 imaginary, plus and minus, and 1 real. And I use the grouping method to factor that. Coming down to 5. All right, we're going to have 4 total answers for complex. The imaginaries come in evens. So that could be 4, that's an even, 2, or 0, imaginary. If you get 4 imaginaries, that would be 0 real. If you get 2 imaginaries, you would do 2 real. And if you get 0 imaginaries, you would need 4 real. Again, those are all got to add up to 4 because we have to have 4 total. So these are our reals, possibilities. Speaking of possibilities, let's go ahead and get the possible rational roots. Take the back number, 8, list its factors, 1 times 8, 2 times 4. Take the front number, list the factors of 1, which is just 1, and divide. 1 divide 1 is 1, 2 divide 1, 4 divide 1, 8 divide 1, give everything a plus minus. If this thing, not saying it does, if it has pretty answers, it comes from that box. Let's look, oops, sorry. Let's look at the signs of f of x. So that is our original function. This is positive, positive, positive. So we will have 0, positive, real roots because we had no sign changes. Look at f of negative x. Even, and then he always stays the same. So even stay the same. Plus, plus, plus. We're going to have 0. Negative real roots. Okay, so that makes me think, well, that we have no real roots, right? If they're not positive, they're not negative. I think we probably have this situation where we have 4 imaginary and no real. Let's see. Let's actually solve it now. Again, it's a trinomial, so I'm going to try to do the magic X. It doesn't always work, but I'm going to try it. I put a 1 here, and I multiply the front times the back. So that's 8. The middle number is 6. Multiply to 8, add to 6 would be 4 times 2. So the factors, see this x4, split that up. 2 for me, 2 for you. And their magic numbers was a positive 4 and a positive 2. Set to 0, this would come over. X squared is negative 4, root, so x is 2i plus or minus I because he was negative. Set to 0, this will come over. X squared is negative 2, root, so x is I root 2 plus or minus. So yes, my hypothesis is right. We end up with 4 imaginary solutions. Number 7, last one on the front. Alrighty, you think he'll be easy. It's actually not, because he's so short. All right, so we're gonna have 3 total or 3 complex roots. Do the imaginary, they have to be even. So that's 2 or 0 imaginary. If you have 2 imaginary, that leaves room for 1 real. If you have 0 imaginary, that would be 3 real. Let's do our possibilities for our rational roots. These are just possible. That doesn't mean they actually happen. Take the back number. Factors of 1 is just 1. Take the front number. Factor of 1 is just 1. 1 divided 1 is 1. Give it a plus minus. So if this thing has pretty answers, it's that. It's either regular 1 or negative 1. Let's look at our signs. F of x. This is positive. This is negative. So we have 1 sign change. So we will have 1 positive real solution. And let's look at the signs of f of negative x. This is odd, so it will change. It was positive, so it'll change to minus, and the naked number just stays. So that has 0 negative real solutions because it's no change. And again, on the negative x, if you just remember the trick that the odds change and the evens stay the same, by powers, that will help you go faster. Okay, now we can solve. X cubed minus 1. This is a difference of cubes. Okay, so in an algebra 2, you most likely learned how to factor these. They just don't come up very often. I use something called the SOAP method. And what you're going to do is you're going to set up a little parenthesis and a big parenthesis. In the little one, take the cube root of the front guy, so that would just be x. Take the cube root of the back guy, so that would just be 1. And you're going to keep that same sign, S for same. In the big one, take the front guy and square it. Take the back guy and square it. And leave a hole. In that hole, multiply these 2 together. So x times 1 is just x. Do the opposite symbol right here. So we kept it the same as a minus. So the opposite would be plus. And then this one's always positive. That's the factorization. And I have a video on the SOAP method. If you need that, just look on my channel and type in SOAP or factoring cubes. It's there. It's either in the Algebra 2 playlist. It's probably in the Algebra 2 playlist. But I definitely have a video for that if you need to see that in more detail. Okay, set to 0. This will whip around and x is 1. Well, there's our real solution, and it was in our possibilities. Okay, now the other guy here is a 1, 2, 3. So I could try to do that magic X. Oh no, but nothing multiplies to 1 and adds to 1. If I do 1 times 1, that multiplies, excuse me, that adds to 2. So that won't work. We're going to need to do quadratic formula. Negative b plus or minus b squared minus 4ac all under the root 2a on the bottom. So all our a, b's, and c's are 1. That actually makes it pretty easy. I mean, not that it's easy, but you know what I mean. So this would be negative 1. This is our a. This is our b. This is our c. Plus or minus 1 squared is 1 minus 4 times 1 times 1. Who cares about that? All over 2 times 1. Who cares? There we go. So that would be negative 1 plus or minus negative root negative 3 all over 2. So negative 1 plus or minus I root 3 all over 2. And there he is. So we had 1 pretty and 2 imaginaries. So we had, yeah, we had this one. Okay. Flipping over, continue with the odds, number 9. Going to have 3 total answers because that's the highest power. 3 complex. Okay, go for the imaginary. It has to be even, so the biggest even that we can do is 2, or we can do 0 imaginary. If it's 2, that would leave room for 1 real. If it's 0, we would have 3 real solutions. Possible rational roots. Take the back number. Factors of 6 are 1 times 6 and 2 times 3. Take the front number, divide, and there's our possible. Give each one a plus or minus. So if this has pretty answers, it must come from that box. Let's observe the signs of f of x. We have positive, negative, negative, positive. 1, 2. So we're going to have 2 or 0 positive real roots. Again, if it's even, just keep going down by, or whatever it is, go down by evens. And let's observe the signs of f of negative x. So this one would change to be, it was positive, so now it's negative. This stays the same. This would change from negative to positive. This stays the same. So we have 1 negative real root. I can't go down, right? Because if I were to go down an even number, that would put me at -1, and that makes no sense. So it's just 1. Okay. Now, I'm going to try to do this by grouping, because again, it has 4 pieces. So x cubed minus 2x squared minus 3x plus 6. You put the front 2 in a group, the back 2 in a group. GCF is x squared, leaving x minus 2. GCF, let's do minus 3, leaving x, and then 6 divide -3 would be minus 2, because these have to match. That's part of the grouping method. Put the lonely stuff together, so that'll be x squared minus 3, and the one you see twice, just bring it once. Set to 0, this one would just be x equals 2. Set to 0, this one would be x squared equals 3. Root, so x equals plus or minus root 3. So there we have it. We have 2 and plus minus root 3. So we had this situation. We had no imaginary, 3 reals. The pink says we should have 2 or 0 positives. Well, there's 1 positive, there's 2. And then the blue says we should have 1 negative. Oops, I didn't switch to blue. The blue says we should have 1 negative, and there it is. And we have 3 total. That was number 9. Used a grouping method again to help me on that. Ooh, number 11. Cranking it up some here. Okay. Well, you're going to have 5 total answers. So 5 total. That's 5 complex. Go for the imaginary. So that would be any even. So the biggest even I can get in there is 4. Now decrease by even. So 2, 0. That's your imaginary situation. If it's 4 imaginary, that would leave 1 real because it needs to add to 5. If it's 2, that would leave 3. And if it's 0, that would leave 5 for your reals. The possible rational roots. Take the back number, list all the factors of 48. That has a lot of factors. 1 times 48, 2 times 24, 3 times 8, 4. Is that it? 4 times 6? Somehow I was thinking more. 1 times 2. No, I messed that up. 1 times 48. Let me leave some more space. 2 times 24, 3 times 16, 4 times 12, 6 times 8. There we go. That's all the factors of 48. And then divide all the factors of your leading coefficient, which thankfully is just 1. So 1 divide 1 is 1, 2 divide 1 is 2, 3 divide 1 is 3. So just copy that list over, giving each number a plus or minus. So we have lots of possible answers here, which usually does not bode well, but it's okay. Those are the possible answers if it has pretty answers. Not saying it does. Okay, let's observe the signs of f of x. So the original function here started positive. Oh, positive all the way. 4, 3, 2, 1. So we're going to have 0 positive real roots. No positives. Let's observe the signs of f of negative x. Okay, anything with an odd power changes. So this was positive, he changes. The even stays the same. This was positive, he'll change. Even stays the same. This is odd because of the 1. He'll change. And the naked number stays the same. Ooh, okay, so this changed once, twice, 3, 4, 5 times. So we will have 5, 3, or 1 negative real roots. Okay, now we're ready to solve. There is no like quick way to factor this. It's just too long. Grouping doesn't work. My little magic X doesn't work. It's not a sum of cubes or whatever. You just have to start guessing into synthetic division. I have another video if you need more particular help on doing synthetic division. Just look on my channel, either in the Algebra 2 or Pre-Calc playlist. You're just going to guess from the list. But look, we know we have 0 positives and we definitely have some negatives. So guess a negative. So let's set up synthetic. You put a little box to the side and then you put all your coefficients. So we're putting 1, 2, 11, 22, 24, 48. Okay. See how 11 and 22, that's like times 2, and same right here. So I'm going to guess a 2, but I won't guess the positive one because this doesn't have any positive answers. I'm going to guess a negative. Now you drop down, multiply, add, multiply, add, multiply, add, multiply, add, multiply, add. And you know it works if you get that last number to be 0. That's your remainder, and we need that to be 0. This is an answer. X equals -2 is an answer. Now that was just a lucky guess. I could have guessed anything out of the possibilities. Again, guessing a negative because we know we don't have any positives. If that wouldn't have worked, I then would have tried just something else out of that list, keeping it negative. But that worked. What's left over? So this is your remainder. Don't care. He's naked. X, x squared, x cubed, x4. We don't care about the zeros. So we have x to the 4th plus 11x squared plus 24. Now that's a 1, 2, 3. I'm going to try to factor that. 24 and 11. Can we multiply here, add here? Yes, 8 times 3. So split this up. This would be x squared for me, x squared for you, because we had 4, so you cut it in half, plus 8, plus 3. Set to 0, set to 0. I'm going to have to erase some stuff. I'm going to erase the possibles. So we have x squared plus 8 equals 0, and x squared plus 3 equals 0. This will come over and be negative 8 root. That's 2 times 4, 2 partner. So that'll be a 2 on the outside, a 2 back in, and an I. Don't forget your plus minus. Boop. This will come over. Root. Oops, that's negative now. Root. So this will be I on the outside. 3 does not break down because he's prime. Don't forget your plus minus. So there's 2 answers. There's 4 answers. There's 5 answers. So we had this situation. We had 4 imaginary, 1 real. And we had the 1 negative. Real. So if you really want to write this pretty, it would be x equals negative 2 plus or minus I root 3 and plus or minus 2i root 2. Woo! So synthetic had to come into play there on number 11. And I just got lucky with a guess. To tell you the truth, I did this problem earlier on a piece of paper. If I wouldn't have guessed right, I would have just kept trying out of the list of possibilities. And last one I'll be doing is number 13. We need 6 answers total. So we will have 6 total, which is 6 complex. Okay, so go evens on the imaginary because they always come in sets. So that could be 6, 4, 2, or 0 imaginary. If you have 6 imaginary, that would be no room for a real. 4 would leave you 2, 2 would leave you 4, 0 would leave you 6. So those are your possible for real solutions. Speaking of possibilities, what are our possible rational solutions or roots? Take the back number, all the factors of 1. Take the front number, all the factors of 1, plus or minus 1. That is the only thing that could come out pretty. And by pretty, I mean rational. Let's observe our signs. Signs of f of x. We have a positive, a negative, a positive. 1, 2. So we have 2 or 0. Positive, real roots. Let's observe the signs of f of negative x. He's even, won't change, so that'll stay positive. Even, won't change. Even, won't change, and then the naked number doesn't change. 1, 2. So we have 2 or 0. Negative, real roots. Okay, there's all our information. I'm trying to think, can I group this? Because it is 4 things. I'm going to try to group it. It may not work, but I'm going to put the first 2 in a group. I'm going to put the back 2 in a group. GCF here would be x4, leaving x2 minus 1, because there's invisible 1 there. And then I'm going to pull out a negative, leaving x2, and then 1 divided negative 1 is negative 1. So that worked, right? So I pulled a negative 1. Put the lonely stuff together, this guy with this guy. So x to the 4th minus 1, and the one that you see twice, drop down once. So that did work. The grouping worked because the leftover stuff has to be the same. This is a difference of square. Bump, 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 bump. Take the square root. X squared for me, x squared for you. Take the square root, 1 for me, 1 for you. Plus here, minus here. Technically, these are still difference of squares, so I could keep going. I just don't want to. So let's set all these equal to 0. So this guy, I'm going to come right here. X squared plus 1 equals 0. This would come over. X squared is negative 1. Root. The square root of negative 1, by definition, is I. Don't forget your plus or minus. And then this, we don't need to solve twice. Let's just solve it once. X squared equals 1, root, so x equals plus or minus 1. And then this would be the same. X equals plus or minus 1. There's our 6 answers. However, we don't need to repeat ourselves. So here's how I would say the final thing. I would say x equals plus minus I And then I would say 1 with a multiplicity of 2. See how this positive 1 happened once and twice. And then I would say -1 with a multiplicity of 2. So this -1 happened once and twice. So we do have 6 answers, but not really because of the multiplicities. We do, but we don't. Okay. Alrighty, I hope this was helpful. If you feel like you'll need more and you want me to come back on another video and do the evens, just comment on the YouTube video and I can. But hopefully this got you going and now you can try the evens on your own. Okay, I will leave you to it. All right, good luck. Bye-bye.